Coming to the objectives of my research, the main objective of the study is to develop a planning approach in order to select the walling materials, considering the life cycle thinking with the aid of eco-efficiency practices. In order to achieve the main objective, the following sub-specific objectives have been identified. Defining the cost components at different stages, then to devise a mechanism to quantify the operational energy and to determine the carbon emissions due to embodied as well as operational stages. In order to achieve the above objective, the following methodology was adapted. It has been developed in 5 phases. The data collection and the database preparation was conducted in phase 1 with the aid of literature review and expert interviews. In phase 2, the local materials that are used for walling construction have been identified. In phase 3, the life cycle cost and impacts have been assessed. Under the life cycle cost, initial, operational, maintenance, and end-of-life stages have been considered, while under the life cycle assessment, the emissions due to embodied and operational emissions were calculated while neglecting the end-of-life emissions with the proper literature evidence. Then energy modeling with Design Builder has been carried out to find the energy requirement. Moving on to phase 4, the eco-efficiency framework has been developed by dividing life cycle cost by life cycle assessments and by normalizing to the base case scenario. A case study approach was selected as the technique to analyze the cost elements and energy emissions and to compare the selected walling materials over long run. And under the phase 5, I have made my conclusions based on the case study results. This is the case study model house that was used for comparison of different walling materials by considering life cycle cost and impacts. The Design Builder model has been shown, and the life cycle cost and the life cycle impacts are separately computed, and eco-efficiency was calculated in order to compare the walling materials with respect to economical and environmental concerns. The initial cost. It includes the material, labor, equipment, contractor profit, and other costs, and it is contributing to the life cycle cost. It is basically the cost we put to build the house. The values have been calculated for houses with different walling materials, and it is evident that the brick wall is costing more at the initial stage, while CSED is costing the lowest. The operational cost is the cost we spend for the energy use day-to-day consumed by the utilities, and the material selection has a significant impact on the performance of the house and the operational energy consumption. The house with cement sand blocks as walling material consumes more energy, while CSZB is consuming the lowest. Discussions have made with a group of engineers in the industry in order to quantify the maintenance cost, and during the end of life stage, it was assumed that no salvage value was obtained from the buildings and the demolition has been carried out for free of charge. Then the cash flow has been prepared for 50 years with the assumptions shown, and the net present value have been found for houses with different walling materials. And what we see is an interpretation of net present value of the houses with different walling materials, and it could be noted that though the bricks cost more at the initial stage, the overall cost is not that high than the other materials. So, life cycle cost gives a better understanding than just considering the initial stages. Moving into the life cycle assessment, it has been carried out as embodied emissions, as